Hi, and welcome in this presentation, LLM as a guide, an approach for unsupervised economic relation discovery in administrative documents. In France, what we can call local governments, or maybe public administration, which is going to refer to cities, regional administration, or maybe provinces administration, are incent to be an economic actor for the local economy. So they are incent to bond with the local market, to get furnished in goods and services, or maybe to financing some project. So local governments have an impact on their local economy. So they are required to issue textual document in open access because they have to make decisions, because they have to discuss about the kind of project they want to make or the kind of needs they're gonna have. So it needs to be transparent for the citizen. So they have to issue it in open access. So from this starting point, we have a lot of unlabeled data, and we ask in my research project, is it possible to run an economic analysis only through the textual production of an economic actor? And in this paper, because we have a lot of unlabeled data, we want to see how do we define the information to extract if we don't know what to expect. So we know we have unlabeled information, and we know we have some information to extract, but we don't know them. So how do we extract them from this point? So we are in an information extraction problem, and more precisely on a relation extraction task. So how does it look in its basic form? We have two arguments, which gonna be normally named entities and a relation between them. So in this example, you have Steve Jobs, which is a person, a place of birth, San Francisco, and a date of birth, the 24th February, blah blah blah. And so we have two kind of relation which are very easy to guess, born in and born on. So it's written in the text, it's very explicit, and basically it's how it works. But for us, it's going to be more complex because we have a lot of implicit stuff and no label data. So our motivation is that we are more in an open relation extraction problem than a relation extraction because we have unlabeled data, but in open relation, most of the time, the study always used annotated data to make evaluation. So there is no system which just are made to discover unknown information. And so how do we define the relation to extract? What we want to propose is a zero-shot approach to discover a known relation in unlabeled data using LLM as a guide to help domain experts. And what we do is to do an evaluation on different LLM on this task with GPT, Llama, and Mistral on two annotated datasets, with Bizrel, a French economic annotated dataset, and Furel, an English general relation annotated dataset. And what is our first experimental setup? So to begin our exploration of administrative data, what we want to do is to use only one city for the beginning, which is called Lambesc. It's a very beautiful city from the south of France. We extract more than 800 sentences, which include more than 2,400 name entities, mostly composed of organization, localization, and persons. So we have a small example of what kind of text we use. So the town hall of Lambesc informs the assembly that the commune has applied to the sufferer another organization for the acquisition of a land in some place. So what we can see is that like the first organization, Lambesc City, and a private organization, Safer, are related by an acquisition of land. So in this case, it was pretty simple, but we're gonna see that throughout our experiment, most of the knowledge is implicit, so it's not that easy to label a relation. So what is our pipeline? We start with entire documents, which could be several pages. We split them in sentences. We use a model trained for name entity recognition in administrative document to make a first filter. So we only keep the sentences who at least get two entities in the sentence or more. And then we send those sentences with two entities or more to a LLM. In our case, it was GPT-4o, and we asked the model, do you see a relation in this sentence? If the model says yes, we keep the sentence. And then we use the sentence to create some clusters. So we made several experiments, and what we want to retain is the fact to create clusters using entity couples. So you're going to use the entity labels like organization and organization, maybe organization and person, or localization, localization. At the end, we had like 5 different clusters, uh, and we tried to discover what kind of relations we could find in those sentences. So we use all the sentence of a same cluster, and we send it in input to LLM. And the point is to ask the LLM, do you find any relations? And if there is repetitions, could you provide the name of the relation, a definition, and some example from the input text? So at the end, you have a list of potential relations, and what we do is that we work with some domain experts. So in our case, there were 3 people which work in a company specialized in selling information about administrative documents for application, mostly of public documents. And so we analyze with them, is the relation, is it true positive, is it false positive, or is it just a duplicate maybe of something we already seen in the experiment. And at the end, you have a relation typology. So to evaluate our process, to explore a bit and give you to give you a bit of results on administrative data. So we use 2 setups, one with random creation of clusters. So we just randomly picking sentences to create clusters, and then we use the entity clusters I present you. We calculate precision because we have true and false positive, and we estimate a recall because we calculate an alternative version of recall because we needed false negative to do so. So we base on the maximum number of positive relation we have found in our experiment to calculate recall. So it's not a perfect score. It has a little bias towards the best model, obviously, but it was the point was to emphasize the fact that the number of relation is important and the quality of it is important. So what we see is that in the entity setup, we have the best results, and GPT-4.1 gets best recall. So like it discovered 14 different relation, which is very good. We see that smaller models struggle a bit more to discover a known relation, and especially they struggle to make clear and meaningful names for the labels. When we look at the annotated data, so we have BISREL, which is a French corpus containing 6 relations. GPT models always trust the evaluation. It's the same for FURL, which contain, in our case, 16 general web relations. But we see that in both cases, the model could not discover every relation because maybe there is some weakness around certain topic. For BISREL, it's because we have a relation called others. And for FURL, it's some repeated topics like mother of or subject of, which always never been discovered by the model. So in conclusion, our methodology provides an annotation guidance using LLMs. Experts must appreciate the ability to identify a wide range of relation and clear meaningful labels. GPT demonstrates strong abilities, but also exhibits repeated weaknesses. We already done an experiment at a national scale to observe the relevance of our approach, and the future step is to create an annotated dataset for administrative information extraction. Thank you for listening, and do not forget to visit the city of Lambesc.